Hello everyone, welcome to my Your Programming Club. Today we will be solving another daily LeetCode problem, and the problem's name is longest happy string. Okay, so there will be a string s which will be called happy if it satisfies the following conditions. Okay, and those conditions are that the s only contains three kind of letters or three letters A, B, and C only. Okay, and s does not contain any of triple A, triple B, or triple C as a substring. Okay, so you cannot have more than two consecutive A's. Okay, because that will result into a substring of triple A. Okay, or similar will be the case for B and C. So you cannot have more than two A's or B's or C's consecutively. Okay, and S contains at most A occurrences of letter A, and S contain at most B occurrences of letter B, and S contains at most C occurrences of letter C. Okay, so these number of occurrences of each of the characters A, B, and C will be given to you as input, and you have to form the longest possible happy string that you can. Okay, and if there are multiple of those, you can return any of them, and if there is no such string, then you have to return the empty string. Okay, so a substring is a contiguous sequence of characters with a string. Okay, within a string. Okay, so this is a substring, uh, and this is also a substring. Okay, and this whole is also a substring. Okay, so the sequence of characters should be contiguous. Okay, no matter where you are starting, so it should be contiguous. It should not be like you are taking AC till here and then you are taking CC till here. Okay, so it will not be a you know contiguous sequence, so it should be contiguous. Okay, so I think now you are clear with what a substring is, and before thinking of an approach, let's have a quick look at the constraints. So according to the constraints, the A, B, and C characters will be of order 100, and number of those characters that will be given to you to form the string, and summation of the number of those characters will always be greater than 0. Okay, so basically you will be given, let's say we are given 7 A's here and 1 B and 0 C. Okay, so from these characters we have to form the longest happy string we can. Okay, happy string is a string which satisfies all these properties. Okay, so let's try to think how we can solve this particular problem. So see, consider a situation where you are given following input, that this is the input given to you. Basically you will be knowing that how many A's we are having. Let's say we are having X A's and Y B's and Z C's. Okay, so these are the character frequencies which we are having, and we want to construct longest possible happy string that we can. Okay, so let's say that we provided this information, that how many frequency of each character we are having to a magical box. Okay, and we also told this magical box that you have to always give us out uh, maximum frequency character entry. Okay, by maximum frequency character entry I mean that, let's say A is occurring 15 times, then B is occurring let's say 16 times, and then C is occurring, let's say 20 times. So whenever you will be asking the magical box for the maximum frequency entry, it will be giving out this particular one. Okay, because as of now C is having 20 frequencies. Okay, so that's why it will always give out the maximum frequency character entry. Okay, by entry I mean the pairing of character with its frequency. Okay, so then you will let's say ask this uh, magical box what is the maximum current max frequency element entry. Okay, it will give you out that, let's say it return the answer as that A is having 15 frequency and it is maximum right now. Okay, so let's say this portion of the string you have already formed. Okay, now you will see that if you place a after this. Okay, so let's for a moment assume that this b is not here, and if we place another a here, then it will result into triple a, which was not allowed, by the way, so it will violate our rule. Okay, so we would not be doing that. Instead of that, what we would be doing is, in that kind of situation, we would be asking the magical box or the magic box that, hey, what is the second max frequency element? Okay, or the second max frequency element entry, and it will let's say answer your question with a particular uh, entry, and b is occurring let's say 11 times. So you see, we can definitely place b here, and its frequency will be reduced from 11 to 10. Okay, and we place the b here, and then what we will do, we will provide these frequencies back to the magical box, as they are still not zero and they still can be used. Okay, further down the line. Okay, and if let's say there is no such case, and your the string that you have formed till now is only a. Okay, then you would have easily placed uh, a here, and in that case 15 would have been reduced to 14, and you would not have asked what is the second max frequency. Okay, in that particular case you would have placed a here. Okay, so I hope the logic is clear to you. First of all, you will go to the magical box once you provided the information of how many character frequency we are having for each character, and then you will tell the magical box that you have to maintain, always give out the maximum frequency character entry. Okay, so whenever you will inquire do an inquiry about the maximum frequency character entry, it will give you out that. Then you will decide whether you can place that character into the already formed happy string. Okay, if you can, then it is no issue if it is not violating that rule or triple a or triple b or triple c. And if it is violating that rule, then you will again ask what is the second max frequency entry. Obviously this time the first maximum that you have already taken out will not be returned, and the second max will be returned this time by the box, and you will take one of the frequencies of that character and add it to the string happy string, and then you will give out both of the entries, saying that okay, update yourself with these entries. Okay, so this is what we will be doing. This is kind of a simulation that you can think of, and now let's see how we have implemented this in the code. Okay, and by the way, this magical box, for implementing this kind of magical box which is already always maintaining a certain order, we will be using a data structure called heap. Okay, essentially heap is of two types, max heap, the one that we will be using here. As the name suggests, it will always give out the maximum entry. Okay, and min heap. Okay, so if you are I would also recommend it also, that you should be, if you are not familiar with it, you should be heading over to the description box, and a link of an article regarding heap will be provided there. You should definitely check it out and have a good understanding of heap before proceeding with further down the line with this particular video solution. Okay, so now without further delay, let's take the code to the board. So let me adjust it a little bit. Yeah, I think now it should be fine. Okay, so as we discussed that we would be giving some entry values to the magical box. So to construct those entry values, we have declared a class. Okay, the class is nothing but each object of this class will be having two properties. One will be the character. Okay, and second will be its frequency. Okay, for example, a is occurring 15 times, so it will be something like this. Okay, so these objects you will be feeding to your magical box. Okay, or magic box. It is heap here, max heap to be specific. Okay, so it will be having the max frequency element at the top. So max frequency heap, it's is it name. Okay, you will be feeding these characters. Okay, and these objects, to be specific, objects of this particular character frequency class. Okay, and you will only be constructing these objects if their frequencies are greater than 0. Okay, and once you feed that information, then you will start the building of this particular result that you are looking for, the happy string. Okay, so you will be doing the whole process till your frequency heap or the magic box becomes empty. Okay, or you violate some condition. Okay, so what you would be doing here is, till your magic box becomes empty, you will do the following things. Okay, for a moment, I'll be adjusting the code a little bit, and I'll be inserting some spaces in between. Yeah, I think now everything should be clearly visible, and it will also not confuse you. So what we would be checking is, if now we will take out the current maximum frequency entry for the character. Okay, maximum frequency pair we will be naming it. Okay, and we will be seeing what is the current size of the happy string that we have formed till now. If the last two characters of this particular string that we have formed till now are same to the character that we have taken out, whose pairing we have taken out of the magic box, then we would be saying that, see, adding this particular character to the current state of happy string, which will violate some rule. Either it will be becoming a triple A or triple B or triple C. Okay, so in that particular case we cannot do so. So we will ask for the second maximum frequency pair. Okay, the pair will be nothing but the character and its frequency. Okay, so you will be taking that pair out. You will decrement the frequency of this pair by 1, since you have used one of its frequency. And if it is still having a frequency greater than 0, then we can use add it for future use. Then we will again feed it to the magic box after modifying its frequency. And since for the first maximum entry that we took out, we never used it, so we would not be modifying anything in that one, and we will be feeding it to the magic box as it is. Okay, so if that is not the case, let's say you are not entering into some kind of this kind of situation, or this kind of situation, or this kind of situation, so in that particular case you can go ahead and just add the current character for the max frequency pairing that you have taken out. That character you will take out, and if it is still having a frequency greater than 0, then it can be used in near future down the line, and you will again feed its object to the maximum frequency box, and before that you will decrement its frequency by 1, since you have used one of those frequencies. Okay, one of those occurrences, you can say. Okay, so once you will be done with this whole process, okay, uh you will be returning your string. Okay, and yeah, and if at any time while doing so that you took out one entry and your magic box becomes empty, then you will say that we cannot proceed any further of making the magic string. Whatever is the state right now, we have to return that. Okay, then you will be returning your magic string that you have formed. Okay, so this is the whole procedure or the process. And the time complexity wise, in heap what usually happens is, if let's say there are n entries in the heap, okay, then each addition and taking out something uh, takes up log of n, okay. But here there will be a case that there will be not more than 3 entries, because we are dealing with only a, b and c. So log of 3 you can take it as a constant, okay, and rest these operations will be performed taking something out and adding it again to the magic box, order of a plus b plus c number of times, okay. So this is kind of a loose upper bound that you can take. So the time complexity will be equal to this. I am ignoring this factor log of 3, okay, and this will be your time complexity. And as far as space complexity is being concerned, see, only at each time, in worst case, 3 entries will be there in the magic box or the heap. So space complexity wise also, we can ignore that thing, because only 3 entries, so it's pretty much constant, so it will be order of 1, okay. So these will be the complexities, and this is the approach. If you are still having any kind of doubts or any queries in general, then you can ask them in the comment section. And I really hope this solution walkthrough added some value to your journey of honing your DSA skills. Keep solving more and more problems, and I'll be seeing you in the next video. Thank you for watching.